Today we're going to talk about counting. This chapter about counting will have many different things. We'll start off with some basic examples of counting, mainly how to organize and different techniques, and then we'll slowly progress to talking about permutations and combinations, but that'll be in a few days. Alright, so what type of questions will we be answering? Here's a typical question. How many outfits can you make if you have 3 pairs of pants, 2 shirts, and 2 pairs of shoes? Well, let's go ahead and label the pairs of pants P1, P2, P3. The shirts will be S1, S2. And not to be confused with the pairs of pants, we'll call the 2 pairs of shoes F1 and F2, maybe for feet. One technique that we can use to count is something called a tree. So I'm going to begin by listing all possible pairs of pants. The next thing that I'm going to do is I'm going to list the shirts that we choose to pair with each pant. So for instance, if we have pant 1, I could either have shirt 1 or shirt 2. If I have pant 2, I could have shirt 1, shirt 2. Or if I choose pants 3, I could have shirt 1 and shirt 2. These are called branches, and hence the name tree. The next option is that I could have the pairs of shoes 1 or the pairs of shoes 2 for each of the choices. And so therefore, for each shirt, I should have 2 branches. And even though this starts to get a little bit cluttered, what we actually have are all of the possible outfits. For instance, if I were to follow this branch, I would be wearing the outfit of pants 2, shirt 1, and shoes 1. When we count these up, we see that we have a total of 12 outfits. Here's another typical problem. How many ways can you roll 2 dice so that the sum of the dice is 5? Now, before you sit there and try to count these up, it's important to realize that you have 2 different dice. So I could roll, for instance, a 1 and a 4, where 1 is on the first dice and 4 is on the second dice, but is that different than rolling a 4 on the first dice and 1 on the second dice? The answer to that is yes. And so what we're going to do is we're going to draw a diagram. The top numbers are going to represent the dice, or the numbers on the first die. The numbers going down the first column will represent the numbers on the second die. I've color coordinated these for you so that you understand that the colors represent the different die. We fill in the table by matching up all of the numbers in the rows with the columns. And what we see is that we have a total of 36 different numbers that can be rolled from the 2 dice. Remember that we're trying to roll a sum of 5, so we recognize that these 4 entries will give us all possible ways to roll a number of 5, or a sum of 5. Now here's another example. How many ways can you draw 5 balls from a hat of 10 balls if you don't put the balls back into the hat? Well, if we think about what's happening here, if I pull the first ball out, I have 10 ways to pull out the first ball, because there are 10 balls to choose from. If I don't put that ball back into the hat, I now have 9 balls to choose from for my second draw. Then I have 8 ways for my third draw, because there are now 8 balls in the bag, or in the hat. And then I have 7 ways for the next one, and then lastly 6 ways for the last draw. I can modify this problem and say how many ways can you draw 5 balls from a hat of 10 balls if you do put the balls back in the hat? Well, the first way I can draw a ball would be 10 ways. I put the ball back into the hat, I still have now 10 balls to choose from, so my second option gives me 10. The third option would give me 10 possibilities as well, and we have a total of multiplying 10 together 5 times. here's a problem that's slightly different in nature. How many squares are drawn below? Now, if you see a problem like this, don't worry and just count it out and be patient. There is no algorithm to tell you about how to go about these problems, but we can at least try to understand what's being asked. Alright, now you probably see 9 squares, and those are all of the little tiny squares that are drawn. But that's not the answer, because there are more squares as well. For instance, we can have the big square, so that gives us 9 of the little ones plus 1 of the big one. But we also have 4 more, and those 4 more come from looking at each of the squares in the corner that are 2 by 2. After that, we really don't have any more options, so we see a total of 14 squares. Alright, your homework is going to have several examples of where you would need to draw trees and diagrams, and some where you just need to draw the pictures out, such as the square problem. Next time we'll come up with a counting principle that will help us understand how to do these.